Hi, welcome everyone. Thank you for attending my session, the last session of the conference. I know it's a bit late, and I'll try to make it as entertaining and useful for you as possible. I'm Ebru Cucen. I work for Continuo as a DevOps consultant, and today I'm going to talk about the serverless challenges that I've been through, what was expected and what I had to do, the workarounds to share so that you don't have to go through the process. I work at Continuo. We are hiring if anyone is interested in. I'm Turkish, vegan. Used to be a developer doing more automation and cloud migrations for the enterprise companies nowadays. But I love learning, exploring, sharing, being part of the meetups. Today, if you will go away with 3 things, those are the things that I will hope you will remember. The first one is the serverless. It's the abstraction of the infrastructure so that you don't have to spend time on the operations, but you can create real business value with minimum investment. The second one is, as this is a new paradigm, I don't know how many of you have implemented serverless architecture design? 1, 2, 3. It is becoming the new kind of trend paradigm, but it does comes with its challenges. It comes with its own architecture design that you have to rethink about what you know, and you have to re-implement with a different perspective. So it's not the old tools, old languages. What you know before may not help you. So it's a different perspective. And the last one is kind of the project I worked on was Azure, so it's a bit different than AWS. I'll try to make the differentiation as much as possible. How many of you have worked with AWS? Half of it. Any other cloud provider, IBM or Azure? It is kind of a mixture, so it's you will be informed, I guess, what the other offerings are or how do they work. The first one is serverless offering. Simon Martley's, as he puts on, it does enable to put a price tag on what your application flow is. So it's the minimum granular that you can detect and understand how much you are spending and how much your application does require for that specific business feature. It's awesome visibility, so the supply chain of your business can benefit from it. It's very useful in terms of getting the value out of what you put. Martin Fowler's blog post, first time, it was 2014, I believe, 16. It was Mike Roberts has a proper blog post about what the serverless framework is. He has updated as version 2 last week, so if you have a chance, go and read it. It does focus on 3 things: that any serverless offering should be abstraction of the infrastructure management. So you shouldn't think about the CPUs and memories or how much I'm going to spend. It should be pay as you go. So if it's idle, if it's not executing, there should be 0 cost apart from the storage, if you have already kind of allocated storage. But the total cost of the execution process during that time, idle time, it should be 0 cost. And the third one is the autoscalability. You shouldn't scale if there is load happening whenever. It should be autoscale and descale as well when the load goes down. So it shouldn't be part of your configuration, code base, or any other requirement. The difference, we've been through the kind of migration process, the enterprise IT, the old traditional IT. You have to take care of all your stack, creating the data center, networking, storage, servers, virtualization, the runtime containers, applications and functions. It goes with the infrastructure as code. The containers as a service is something that some people use. So you just take the care of your container level abstraction. And platform as a service comes with the applications so that you are responsible for your application code. The difference between kind of serverless and the platform as a service comes with the functions level, so that you don't really care about the whole application, but granular, very specific use case of your functions. It means actually you don't have to think about the security hardening and all the other aspects of the old traditional systems you had to do. And the difference between PaaS and serverless, it's 20 milliseconds, the startup time. So whenever a function can be triggered and up and running within 20 milliseconds, then it is kind of categorized as serverless as well. So if we look at the application level challenges I've been through, the first one was the migration. I'll tell about my story, what the project was about, how we decided to migrate, what patterns we followed. There are proper serverless design patterns, fan out, fan in, chaining, that I will talk through. There are some language trades-offs that what we know may be different that we have to think about. Debugging, and this is my code base, how I'm going to debug. It's serverless, there is no server. I can't log in RDP to the session with RDP to the server and look at what's going on. It becomes more abstract and tricky to find out. Caching and versioning, any application does require a level of kind of help in terms of the speed if you want to cache. Where I'm going to cache it if I don't have a server, or what the kind of means, resources that I can use. Security. Is my application going to be less secure, the function serverless, or is it going to be the kind of harder to secure? Because now we have one application that I have done the hardening. Now I have 20, 50 functions for that specific application. For each one, do I have to go and do sanitization, input validation, and kind of hardening of each process? Is it going to be kind of harder or not? And the networking, do I have to think about networking? This is standalone native application, native function, serverless function that I'm writing. How it's going to connect to the other world, kind of. What can I take back? Is it going to work? What's the constraints of the existing environment, existing network? Do I have to know about it? Can I not think this is the greenfield environment that I will be creating? So these are the kind of topics I want to go through today. The first one was the application challenges. The project started, hey, let's try serverless. The company was a bank, enterprise company, and the decision was straight. We are doing first SaaS, software as a service, and then PaaS, function as a service. If not, then PaaS. If not, then we will go IaaS. So the whole infrastructure team was responsible for automation, serverless, or the SaaS solutions. They were not allowed to do any IaaS implementation. So it was the first time for me as well to see infrastructure team working on a serverless project. That was awesome as well. But the challenges that I will go through. The first one we picked was the easiest one, the postcode lookup service. It's called theme. It is the easiest, smallest, standalone service that you can decouple from the application. By the way, their application was already on cloud, so this is not on-premise application that we are trying to take away. It's cloud-native application written as Azure Web Apps, and the motivation was going to be our taking one API, postcode lookup endpoint, out of this application. So the question was how we are going to decouple. The first one we looked at was the Strangler Pattern. How many of you have been familiar with the Strangler Pattern? 1, 2. It's Martin Fowler's part of the enterprise application patterns. The idea is he was inspired with this fig tree it takes a tree, and it wraps around it, and it takes its root to the ground, so it grows. By the time it's kind of strong enough, the tree in the middle disappears or dies, so it's just strangled in a sense, kills it. But then it survives, so the end result is the fig tree standing on its own without the original tree in the middle. So the design is we will keep the existing application and the existing code for the postcode lookup API. And then we will move it as a Neve service, kind of Neve serverless function. You have two options there. You can either refactor within the application and then move the code to the Neve function, or you can write brand new one. The recommended version is the original one, so that you do minimum changes. In a sense, you do test and move the code as is. But Azure Functions and all new paradigms comes with its offerings, so it can be helpful to think about your design architecture and refactor the code base. Also, you can rewrite the code in a different language. You are not tightly coupled with what the previous system is. And actually, we will see it can be beneficial to rethink about the language and write in a different language as well. And the last one is either with a proxy layer, if there is no proxy layer, adding another proxy layer to redirect the call and either leave the code, old API, in the existing application or remove it. It depends, because you may want to have the fallback option still available if something goes wrong. But then you redirect the call to the new application. So in a sense, you strangle the old application and created the brand new application on its own, alive, working. Sorry. OK, I have my postcode lookup out of the application stack. We are successful. It's working. Then the next step, so we want to migrate more. Sorry. So the next one is how we are going to connect back to the application if the connection is deeply buried in the system and you can't do the direct calls to the register customer or any other application. Sorry, API. This pattern we did evaluate was the branch by abstraction. It's well known as feature toggling as well, in a sense. Sorry. The branch by abstraction pattern happens, the code base, the API, user registration API. You do implementation and abstraction of the user registration. So you create another endpoint to be able to call. Postcode lookup in this scenario will just check the user registration abstraction, whereas the old working environment will work as is. The next one is to make sure that this implementation has a Neve user registration service. So this is the Neve logic you want to implement, because you don't want to you want to introduce new parameters, new logic inside it. And the last one, when you are happy with, whenever the feature toggle on and off, when you are tested, you can get rid of the old user registration endpoint, and just the new user registration service can be implemented. And the postcode lookup, just look at the new user registration, calling the external register function, which you have extracted and implemented as a Neve serverless function. So in a sense, if you look at, we got rid of the postcode lookup, and we can have the autoscale opportunity as much as we want. We have the new user registration service extracted as well. So how do we autoscale and how these functions are going to talk to each other? This is where the design patterns come into place. So serverless, there are so many functions around, and each one needs to talk to another. The first one is the chaining. So it's sequential, synchronous call. So you do call one function and the other. It's called chaining. You have address lookup, and then that should call the phone verification because you have a dependency on the address lookup. And then the user registration is happening as an end result. So in a sense, you are restricted by the sync calls in between. The other pattern is you have one initial call, and then you do the async calls, the parallel calls in between. It can be happening, email checking, email verification, phone verification, or the address lookup happening at the same time. And then you are waiting for the end result, and then register it. It depends on your business requirements. You can implement both of them. But still, these are not helpful if you have external dependencies, if you have to wait. Something should take care of it. If an error happens, you don't know what to do. Do I go to back? Which one was failed? How do I trace which one is going to happening next? There is no traceability across the board. So either the sync one or the pan in, pan out doesn't help you to be able to, on top of the application flow. So what we want to do is we want to have all the actions logged somewhere, stored, so each time we know which action has been played, where it did fail, what was the error message, and if we have to wait for external approvals or the dependencies, we wait for the results, come back, and take action. It is called event sourcing. It's very well-known design pattern, another pattern from Martin Fowler. And the idea is we have an orchestrator client, which is kind of starter function. So its responsibility is to take whatever the call is. It can be a web application, a mobile app, or IoT device, whatever the trigger is. Orchestrator client takes this event data, and it does create a context. It does call the orchestrator. Orchestrator is responsible for calling either async. This example is calling all of them async, but it can be sync calls as well. It knows everything one by one, what the implementation is going to be for each one. And if something goes wrong, or the orchestrator itself dies, because everything is logged in, the storage account, it knows where to start and how to continue. There is another benefit of this one, because every time the orchestrator calls a function, it goes to sleep. So you don't pay for the orchestrator execution time, which is ideal for the serverless offering, because one of the serverless offering, the second one was pay-as-you-go. If it's idle, if it's not working, I don't want to pay money. So Azure durable functions kind of is the setup, does help you in terms of the orchestration, and you can do all the logging implementation with confidence. So if you look at kind of the basic example, this is the starter function. All it needs, the orchestration client attribute. So the durable orchestration client is the starter. It does take basic HTTP request message, and you can define the authorization level, the security levels you want to implement. It does create an instance. Behind the scenes, it does create a container instance. If you don't provide an instance ID, it will generate a brand new one. And the create check status response will give you the endpoints, in a sense, which is the state, what's the status of it, how to terminate it. There are 4 JSON output of it that gives you the URLs for the status check. So this is the starter function responsible, triggers the orchestrator. As start new async. The orchestrator function is responsible for the context. it can't do any thread operations. It's because it should be replayable. In a sense, every line here is going to be stored in the database as part of the event sourcing. So every time the orchestrator is triggered, it will loop through one by one and check if the line has been executed or not. If it has been executed, it will move to the next line. And then if it's not done, we'll go to the context call activity thing, whatever the activity is, execute that, and comes back to the next one. It's great for keeping track of what happened. You can't use datetime or real-time data, but there is supporting helper functions to define the context.udc datetime, or depending on the application-specific relevant data if you want to. And if any error happens, you can handle here, so putting a try-catch block covering all of the activity functions. You have a single brain responsible for the management of your activities. And this is one of the examples of the activity. It just needs the activity trigger attribute. Whatever you tell it, either it's async or sync operation, it will execute it and return back to the orchestrator. Very simple. OK, we have done kind of the durable functions as well. We know how to orchestrate it. If we have multiple functions, we are comfortable with it now. The other one questioning is the type of the functions we want to move to serverless. Always on, does it have to be? Because the difference between the past solution and the fast solution is you don't need always on. But I want to have kind of a comparison between if I had the VM, what was my kind of IaaS option to implement. This is kind of, I went through to compare the differences for the Azure. Tim Wagner has done the AWS Lambda comparison in the link. How much does it cost for a 3-yearly plan? So I went through the pricing calculator and find out what the one concurrent for 1 gig RAM. It does autoscale, you don't have to tell, but my assumption is I have an execution function that does require 1 gig RAM. And the resource consumption is 2.6 million per year it makes, but the first 400,000 is free, so it's 2.2 million gigabits per month. It makes £950. The execution is per number of executions. It was 2.6 million. The first 1 million is free. So I said 1.6 million executions, which makes £8 per month. So in total, thinking this is a 3 years plan, 959 kind of pounds that I will pay for a serverless offering. That's why it's kind of quite attractive. A Cloud Guru or any other application is that they do offer this as kind of really easy to operate, really easy, really cheap option for your applications. The other option was a standard VM with 2 CPU, 4 gig RAM. It's annual 313 pounds for 3 years. It's 939. So, I mean, thinking that the serverless is a bit expensive than the normal offering, I would be better off with my IaaS solution. I don't have to take care of. Serverless is not real at scale cheap. But for the offering to compare really the difference is there is no HA in the IaaS solution. You have to have another VM. You have to have a load balancer, a router, to make sure that you have the high availability. You don't have the queue storage, kind of apart from its the function as well. So rethinking back, I have 2 standard. They are burstable, the B series, £240 per year for the load balancer, In total, it makes, for the 3 years plan, £2,598. This is quite different. And on top of this, because I have my VM, I have to think about my security hardening process, update, patch management, and all the things that we used to do that I don't have to take care of it. So it's a really good offer, in a sense, where we want to use, where we want to move forward. And the third one is the language trade-off. So there's something called cold start. I don't know if you heard of it. But every time we do trigger a function, it does need to warm up. It happens with all the web servers, actually. But when it's the container, then it's a bit tricky. So this is one of the examples of the version 2 of Azure Functions. The first, and this happens for the first time. There are tricks around it. But the first time you trigger, there is like 12 seconds, 13 to 15 seconds kind of penalty for the time. What you can do, people kind of do another initial call, and then you run your own application, or some people do run scheduled cron jobs, so that it's running every 5 minutes, 5 seconds, to keep the Azure Functions up and running. Or there is a third option, premium option, which is the consumption plan, app service plan rather than the consumption plan. So you do pay the premium price, and the cloud provider does guarantee that it will be always on running. Fourth one was debugging. OK, this is somewhere that I can't RDP on. What I'm going to do, how I'm going to debug. Where is it? Olden days, we had the monitoring. Have you heard of white box monitoring versus black box monitoring? Anyone? In olden days, the monitoring, kind of when we had IaaS machines, we had black box monitoring. We had to go each item and see what the inputs are done. The metrics are collected every frequently, and we had to get the items inside the collect the metrics, the telemetry, and create the visibility of what the application is doing. In the new kind of era, we have multiple distributed applications, and each one does require a tracing ID, because we don't know which one is calling where. And each application does have to emit its attributes rather than someone is telling. Because they are becoming discoverable, in a sense, that which one is, has which IP, which DNS name, where it's generated, we don't know. So each one is created with its own attribute. It becomes the application's responsibility to create attributes and to display them. The old Nagios or the Zabbix, whatever the monitoring tool we have, doesn't display anything with the Azure Functions. So we have to look at the new tools like Abstraction or Thundra. The collection, when we had the telemetry with the old applications, they may delay up to 1 minute. But we need real-time data to be able to trace it, understand what the actual application is running. Because we are talking about the seconds and the milliseconds each time execution is happening and the container or whatever the behind the scenes is running. The fifth one is the caching. So the application does require something. We need to kind of implement, design the caching and the versioning somewhere. The difference between Azure and AWS is here that if you want to publish a function, a serverless function, AWS doesn't let you to have a public endpoint. You have to have implement app gateway. Whereas in Azure, you can just publish it takes seconds, and you have a public endpoint. You don't have to think about the API manager. So this was my challenge to kind of convince people that we do need an API manager. We need to gateway our endpoint. Because as a developer, if I can publish something to the cloud and it's available to everyone, I'm happy, but I'm not done because I need to think about what the other requirements of the application may have. Caching is good for the response times because we talk about the cold start time already is an issue. If we want to have more robust applications, the functions running, we do want to implement the caching. Versioning becomes tricky because every time I make a single change, it's a new function. It's not anymore like my application is deployed. So every contract I have, either on its version, on its URL as a core path, or on its reference name, has the version number, then you start becoming conflicting. And when you have the breaking change, you have to make sure that something is aware of it. Then the API manager kind of comes into play. It's not just the caching and the versioning. Also, API manager does the rate throttling, which is quite important because when we said it is autoscalable, unlimitedly autoscalable, during my test, I can write, by mistake, a function calling, and I can make my function autoscale to 1 million functions in seconds. No one is stopping me, and nothing can stop me by mistake to call an infinite loop. By mistake, I was calling the function, the user registration function. By mistake, I have a kind of loop created and called 1 million times. You still kind of have to pay that money to the cloud provider, whoever. But the API manager does have the rate throttling, so you can tell that this function cannot be called 5 times or 100 times per second, more than 5 times or 100 times per this user with this API key. So it does give a proper endpoint validation, sanitization. So I think I get that API manager deal as well. And one thing was that I don't have to think about the networking. Whenever, as a developer, I talk to the networking person, and there is no proper design documentation that I always have to go through the proxies, the rules, NSG rules, or whatever the applications. I thought serverless will be the perfect place to escape that knots and kind of mess. But I was back to that conversation again. I have to chase the networking people. I have to understand what the network diagram and topology is. Even if they had the on-prem application talking to Azure, they had the proper backend connectivity set up. But still, my application had to talk to the applications on Azure as well as on-prem. So we have to go through and redesign the network topology, how the VNets are going to talk to each other, and how my serverless application have to talk to the VNets. Azure has nice kind of feature, does the VNet integration, so you can tell I can connect to this VNet, but your new application has to talk back to on-prem applications via other means. Now, still, you have to kind of understand what your network topology is. And if you haven't talked about, you haven't talked to the networking team, possibly you are doing something wrong, or you will need to. It's kind of unescapable function. And when we talk about serverless, I said functions, as Azure Functions, as one of the offerings, but functions or the Lambda, AWS Lambda, is not serverless, not only itself. This is the kind of Azure offerings. There are also event grids, event bus, and logic apps. Event grids are mostly responsible for the resources, so you can have pops up messaging system. Any Azure resource, storage account created, function created, updated, so you can auto-trigger and subscribe to new topics on it. Event bus is the reliable message bus queue that it does guarantee the delivery of the order and the delivery of the message as well. Logic apps, for example, is kind of similar to durable functions, what we have seen as activities, but you don't have to write code. Literally, you can drag and drop your flow, and you can manage your logic, kind of, in a sense, business logic, with just the basic workflow. Event Hub for data streaming, if you have hundreds, thousands of data, kind of millions of IoT devices or external endpoints, then you can digest either with the IoT Hub or the Event Hub to display. So it's one of them. AWS has similar offerings as well, in a sense, but don't think that, hey, we want to go serverless, so let's do Lambda. It's not going to end up. You have a habitat of other resources. Just be aware of your environment and understand which is the best solution for your design and architecture, thinking in advance rather than piece by piece moving simple items. That's it, really. I have a couple of references. The Serverless Martin Fowler's website. Serverless Meets is a Tim Wagner's slide from the last year's Serverless conference keynote. Burning Monk is kind of the most popular person to follow if you are interested in. He has written hundreds, if not, blog posts about serverless. And he's AWS hero for AWS Lambda. And there are 3 books. The first one is Martin Fowler's Patterns of Enterprise Application Architecture. It's the book of old architecture designs that you will refer. Working Effectively with Legacy Code, kind of Michael Feathers is nice, tells about what the Strangler, how to kind of get from the legacy code and migrate piece by piece. And Sam News' new book, it's still early release, about how the evolutionary architecture kind of happens. It's a really good book if you are interested in. Any questions? All good? You're all happy? Cool. Thank you for listening.